What is an instruction set? The complete collection of instructions that are understood by a CPU, machine code, binary, usually represented by assembly codes. That's the whole features of instruction set. Elements of an instruction of code, that means operation code, such as opcode, add, sub, multiple, division, div, load, store, etc. Source operand references such as register, memory location. Result operand references, put the result in these result operand references. Next, instruction references, often implicit. When you have done this, do this BR. Example, simple instruction format using two addresses. Whole of the bits is to be 16 bits and that portion is 3 parts. First of 4 bits, middle of 6 bits and last of 6 bits. First of 4 bits is regarded to the opcode. Middle of 6 bits is referred to the operand reference, and last of 6 bits is to be operand reference. Instruction cycle state diagram. This is the whole feature or whole diagram of an instruction cycle state diagram. Here's the total features is to be reflected in this figure. We can start any of the instruction parts and we can, that's ending of the last portion of that instruction. So we can regards as the flow in regards of our such kinds of operation instructions. So we can start or initializing this instruction, that is to be instruction address calculation. That's forward to the instruction phase, and instruction phase is go on instruction operand decoding. Whenever instruction operand decoding is completed, then that instruction is forward to operand address calculation. Whenever operand address calculation is totally completed, then that operand calculation is forward to the operand phase. Operand phase and operand address calculation is to be related in the interconnection. Whenever operand phase is to be forward in the data operation, then data operation whenever data operation is to be completed, then it is forwarding then the next instruction, which is operand address calculation. Whenever operand address calculation is totally completed, then the instruction is forward to the operand store. Here's operand store and operand address calculation is to be related, and that relation is built of multiple results. So whenever operand store is totally completed, then the instruction is forwarding in the initializing of our phase, that's to be as operand address calculation, or that's to be as instruction address calculation, and that's level regards the phase as return for string or vector data, or instruction completed phase next instruction. That's the whole feature of an instruction cycle state diagram. Design decisions. First of one, operation, how many operands, what can they do, how complete are they, data types, length of words, integers, representations, instruction formats, length of code, that means operation code field, length and number of addresses, implicit addressing. Design decisions number 2, Registers, number of CPU registers available, which operands can be performed on which registers, general purpose and specific registers. Addressing modes, see later. RIS versus SIS. What is RIS and SIS? RIS is the invention of the new era or modern initialization or modern type, and SIS is to be the oldest features, that's to be x86 or 32 bits regards, and RIS is 64 bits. Instruction types, data instructions, registers, main memory, stack or input or output, data processing, arithmetic, logical, control, systems control, transfer of control. Data transfer instructions are responsible for moving data around inside the processor as well as bringing in data or sending data out. Examples: store, load, access, move, set, push, pop. Each instruction should have source and destination memory registers, input or output port, amount of data. That's the feature of this diagram, as register I is forwarding register J and last of register K. Whenever register I is initializing and that register I is forwarding to the memory, then register J is forward to memory and last of import port register K, output port, totally connected both of memory and register K. Data transfer instruction example: LD destination source, ST source destination move, destinations XCH destination source push or pop, in or out destination source. Arithmetic: add, subtract, multiply, divide for signed integers, floating point and fact. Decimal minus may involve data movement, may include absolute, for that a mod, increment, for that a plus plus, decrement a minus minus, negation, that means negate minus a. Logical: bitwise operators and or not, XOR, CMP, that means compare, set, shifting and rotating functions. Logical: right shift for unpacking, send 8-bit character from 16-bit word. Arithmetic: right shift, division and transmission or transcation for odd numbers. Arithmetic: left shift, multiplication without overflow. Different shift instructions. This is the whole features of logical right shift, logical left shift, arithmetic right shift, arithmetic left shift, right rotate, and last of left rotate. Systems control and execution flow. The execution flow captures the order of evaluation or execution of fetch instruction. Sequential, branch, loop, produces for function call. Branch, escape, increment and escape if 0, ISZ, raise I, CF, jumping out from loop. Branch instructions: BRZ, X, branch to X if result is 0, BP, BRP X, positive, BRN X, negative, BREX, R1, R2 equal. Procedure, economy and modularity, call and return. Branch instruction: this is the whole features. Nested procedure calls. Address and main memory includes calls and returns and execution sequence. STI, store immediate. LDI or load I, load immediate. Move I, move immediate. This is the total MSB and LSB features. Register 2, register 3, the last of move R2, R3, and this is the total features of an instruction diagram. That's it. Thank you.